So let's continue to learn a new section, section 9.4. Using normal tables to find mu and sigma. Okay, mu is mean and sigma is standard deviation. And firstly, let's do a revision. Okay, so in the last section we have learned that, okay, so if the random variable x is distributed normally with mean mu and standard deviation sigma, and when the probability of x greater than a is alpha, so alpha is a probability, so you write the statement as this one. Okay, so it means that if x is not a standard normal distribution, we will simplify x to be the standard, okay, standard normal distribution z. Okay, so z is standard normal distribution. Okay, it is because the table, okay, the table shows the values about standard normal distribution. Okay, that's why we have to simplify it to be standard normal distribution first. Okay, so actually we use the formula like so. From normal distribution to standard one, we use the formula that z just equals x minus mu over sigma. Okay, over sigma. Okay, and in this section, and also in this section, you will learn some kind of question like neither mu nor sigma is given. It means that both of them are not given. So in this case, you will have to solve simultaneous equations. It means that you have to form two equations to find two unknowns. Okay, two unknowns. Okay, so now let's start. So let's look at example 5. The random variable x is normally distributed with mean mu and standard deviation 3. So it is given that the probability when x is greater than 20 is 0.2. So find the value of mu. So firstly, it is not a standard normal distribution. So firstly, we should simplify x to be z. So we use the way like, so we now x is greater than 20. Okay, so firstly we multiply mu at the same time on both sides of the inequality, so we get this one, and then we divide sigma, okay, which is 3, okay, at the same time. Okay, and then x minus mu over 3 is a standard normal distribution. It means it is z, okay, greater than 20 minus mu over 3. Okay, and then we take the probability, so p z, the probability when z is greater than 20 minus mu over 3, and the probability is still 0.2. Okay, so you see this step. So at the beginning we have x greater than 20. And finally, we can get the probability when z is greater than 20 minus mu over 3, and it's also 0.2, okay? And then we will use the table of percentage points of normal distribution, okay? So this is the percentage points of normal distribution, and we can find that here you see that z is greater than a value equals 0.2. So from on the figure, it must be the small part on the right hand side, okay, the small part on the right hand side, okay, because this value is smaller than 0.5 and z is greater than this value, okay. So of course the region, it must be on the right hand side, okay, on the right hand side, okay. So it is this part. So it means that this is 20 minus mu over 3, okay, this region. And from the table, okay, you see that it is z, okay, z greater than small z equals p. So p is 0.2, okay, 0.2. And the corresponding value for small z is 0.8416. So it means that here 20 minus mu over 3 is 0.8416, okay. So finally we find the value of mu, okay. So we may correct the value to 3 significant figures, okay, which is 17.5, okay. So this is the way to do question 5. So the key point in this question is that, so firstly, okay, so step 1, you should simplify x to be z first, okay. And step 2, and use the table, okay, use the table and the graph, okay, or the figure, okay. You have to sketch the figure, okay, and for you, and it will be very easy to understand, okay. So this is the way to solve this kind of question, okay. And now let's move to question 6, okay, question 6. And question 6 is that the random variable x is normally distributed with mean 50 and standard deviation sigma, and given that the probability when x is smaller than 46 is 0.2199, and find the value of sigma, okay. So step 1 also, firstly step 1, we should simplify x to be z, okay. So here x is smaller than 46, and firstly we minus mu is 50, okay, mu is 50, so we minus 50, and 46 minus 50, and then we divide sigma, okay, divide sigma. And here, why don't we need to change the direction of the inequality sign? It is because sigma is always greater than 0, because sigma is standard deviation. And you can remember that when we calculate standard deviation, it is a square root, okay? It is a square root, so it is always greater than 0, okay? So that's why we don't need to change the inequality sign, but if it is a negative value, we need to change the direction, okay? And after that, you see this is z, okay, this is z. It follows standard normal distribution. So z is smaller than 46 minus 50 over sigma, and take the probability. So when the probability when z is smaller than 46 minus 50 over sigma, okay, simplify it, which is p z is smaller than -4 over sigma, and the probability is 0.2119, okay, 0.2119. And pay attention, this value -4 over sigma is smaller than 0, okay. So from the figure, okay, you should know that, okay, you should know that negative value is on the left hand side, okay, on the left hand side of the of y-axis. So this is negative 4 small z equals negative 4 over sigma smaller than, and this is the region, okay? This region will be 0.2119, okay? 0.2119, so the red region, okay? Represent 0.2119. And however, as we know, in the table, the probability represent this one, okay? It means that small z is on the right hand side of the y-axis, okay? But now you see that small z is on the left hand side of the y-axis. So here we have to use symmetry, okay? So we should use symmetry. So using symmetry, so this value is the opposite value of negative 4 over 6 over sigma, so which is 4 over sigma. And this region, the black region, represent 0.2119, okay? The area represent 0.2119, and this black region, this black region represent the probability of z greater than 4 over sigma, and it equals 0.2119, okay? And however, as I said just now, the table only gives us the area like this, so smaller than small z, okay? But here it is capital Z is greater than a value, so we have to use the complementary parts, okay? Use the complementary region, which is the blue one, okay? The blue one. So the blue region is when the probability of z smaller than 4 over sigma, and the probability is 1 minus 0.2119, okay, which is 0.7881, okay? So we get this one, okay, get this equation. So let's look at the step, okay? So firstly, this is the given condition, and we simplify it to be standard normal distribution, step 1. And then we use symmetry, okay? Why should we use symmetry? Because we should make small z to be positive, okay? So we choose the positive value, okay? So it is 0.2119, and then we find the complementary region, okay? Because we should make it to be the same as the definition in the table, okay? So this is step 2, okay? Use symmetry. And step 3, find the complementary region. And finally, from the table, you see that, okay? You see that the probability for 0.7881 is corresponding to the value of z to be 0.8, okay? So finally, it means that 4 over sigma, the small value of z, okay? Sorry, the value of small z is 0.8, which is 4 over sigma is 0.8. So finally, we can find that the value of sigma is 5, okay? So this is question example 6, okay? Let's record it again, okay? So compare example 5, and you can see that the first step is the same. So we always simplify normal distribution to be standard normal distribution. Make it to be standard, okay? Because the values in the table are about standard normal distribution. And second step, we should use the graph, okay? Use the graph, and also the table, okay? So for the graph, you should understand what is the meaning of the value in the table, okay, in the table. So you will sketch the make a corresponding graph or change the suitable graph for you, okay? So this is the way to solve this kind of question. So that's all.